In another application of the ratio test, we're going to test another series for convergence. This one's a little different. First term is 2/3. Second term is 2 times 5 over 3 times 5. Third term, 2 times 5 times 8 over 3 times 5 times 7. Fourth term, 2 times 5 times 8 times 11 divided by 3 times 5 times 7 times 9. This is different from a series like 2/3 plus 5 over 5 plus 8 over 7 plus 11 over 9. Not only do we have to figure out what the next term is going to be, but each term has a numerator with one additional factor and a denominator with one additional factor. So the number of factors is increasing as the terms move along. Notice that you can predict what would the next numerator would be. 2 times 5 times 8 times 11 times, right, 14. And in the denominator, you can predict again the next factor, 3 times 5 times 7 times 9 times 11. In both cases, you can predict the next term because they're arithmetic sequences. At least the factors form arithmetic sequences. Let's look at the numerator and denominator separately. In the numerator, we have an arithmetic sequence. The first term, a sub 1, is equal to 2 of the sequence that forms the factors, is what I mean. And we have a common difference of 3. That's how we knew that the next 2, 5, 8, 11 was going to be 14, right? Using the formula for an arithmetic sequence, then we have that a sub n is equal to 2, the first term, plus n minus 1 times 3, the common difference. This simplifies to a sub n is equal to 3n minus 1. For the denominator, I'll call it b sub 1 is equal to 3. That's the first factor that we see. And then the common difference is equal to 2. Therefore, b sub n is equal to 3 plus n minus 1 times the common difference of 2, which simplifies so that b sub n is equal to 2n plus 1. With that work done, we can now write the nth term. It'll be 2 times 5 times 8 times dot 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 times, for the numerator, 3n minus 1. And in the denominator, we've got 3 times 5 times 7 times dot 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 times 2n plus 1. What I'd like for you to do now is write the n plus first term and then perform the ratio test and come back when you have an answer. Our n plus first term has a numerator 2 times 5 times 8 times 3n minus 1 times 3n plus 2. That's the next additional factor. We can get that in one of two ways. One, add 3 to the 3n minus 1. You'll get 3n plus 2, I guarantee it. Or, in place of n in the 3n minus 1 expression, put n plus 1. You'll still end up with 3n plus 2. Denominator, 3 times 5 times 7 times the quantity 2n plus 1, and then adding 2 times the quantity 2n plus 3. So here we have our new factors in the numerator and denominator. For the ratio test, we've got the nth term, 2 times 5 times 8 times 3n, oh, excuse me, that's the n plus first term first. 2 times 5 times 8 times the quantity 3n minus 1 times the quantity 3n plus 2 divided by 3 times 5 times 7 times the quantity 2n plus 1 times the quantity 2n plus 3 times the reciprocal of the nth term, so that's times 3 times 5 times 7 times the quantity 2n plus 1 divided by 2 times 5 times 8 times the quantity 3n minus 1. What we see is in the numerator and denominator, 2 divides out, 5 divides out, 8 divides out, all the way up to 3n minus 1 divide out. Moving to the other sequence of factors, 3 divides out, 5 divides out, 7 divides out, all the way up to 2n plus 1 divides out. The only thing we're left with is 3n plus 2 divided by 2n plus 3. The limit as n approaches infinity of that expression is equal to 3/2, which is greater than 1. And so our conclusion is that the series is divergent. I wrote up here that we used the ratio test, and so I didn't have to write down by the ratio test. And there it is.